zoom out a little bit there. I'm going to try to move these around so they're not in the way. Okay. All right, so today, what are we looking at today? Okay, we're going to look at some inequalities, some absolute value equations, and actually it is just to review so that, you know, we're like kind of starting out kind of easy. I told the kids yesterday in class that I really am sorry that you started on Friday with that verifying trig equations and the solving trig equations. All right, because for some of you that turned out to be a little bit more challenging than it would have. Under normal circumstances, you wouldn't have started with that. You would have started with last night's homework assignment. So don't let that scare you or anything, okay? I made several comments in Google Classroom as on those homework assignments. So if I made some comments, you need to go back over, look at those assignments, redo maybe some of the problems, look at the answer key, that sort of thing, especially the solving the trig equations with your graphing calculator. All right, that's kind of important. And even by hand, the solving those trig equations are going to be kind of important. We're not going to do tons of them, but we're going to run into enough trig equations. You're going to want to feel comfortable being able to solve one of those equations. All right, because in all honesty, after we get to about chapter 2 in calculus, every problem is going to start with, here's an equation, and the very first thing you have to do is solve. So you've got to be really proficient at solving equations, because when we solve, that we're going to be finding these things called critical points. Okay, we're going to take the derivative. I should say we're going to take the derivative first, then we're going to solve. But like one of the first 2 steps is going to be solving the equation. So if you can't solve an equation at this point, you're in trouble. Okay. All right. So let's go ahead and date this and get started. Okay, so August 18th. And it's really just review day number 2. We're not really in a section out of the book yet. So review day number 2. We're going to take a look at some inequalities, absolute value equations. We're going to kind of apply everything that we have done. Okay, and so let's just jump right in. Let's go ahead and write down inequalities. That way, if you go back and you're trying to find something in your notes, you're going to have it at least labeled. We're going to take a look at some absolute value equations. Okay. All right, let's suppose that we had absolute value of 5x minus 3 equals 2. All right, absolute value 5x minus 3 equals 2. All right, now what's the deal with the absolute value equations? Yeah, Josiah?
To solve 2 equations, one for 5x minus 3 equals positive, one for 5x minus 3.
Yeah, absolute value equations, you've got to break up into 2. All right. And I always do the first equation, I always just drop the absolute value bars and keep everything the same. So I do like 5x minus 3 equals 2. It is going to be an OR. All right. And then I take the opposite of whatever is on the right-hand side. So 5x minus 3 equals negative 2. All right. Then those are 2 like, 2-step equations. You guys can do this. 5x equals, let's see, add 3 to both sides is 5. Whatever you do, don't let me make a mistake. All right, add 3 to both sides, 5x equals 1, x equals 1/5. Okay, now for the most part, we might have in an algebra 1 and algebra 2, maybe even in a pre-calc, I might have let you write your answer like that, maybe with the word or in there and circle it, but you ought to really get used to, you got 2 answers, put it in set notation. All right, so you got a 1/5 and you got a 1, okay? So that's kind of like a better mathematical way to write it. Use that set notation, okay? Now, same concept, all right, same concept. Move this over a little bit. I don't think in pre-calc we did a lot that had absolute value on both sides. So absolute value 4x plus 6 equals absolute value of 2x minus 7. Concept's going to stay the same, okay? I broke this up into 2 equations, and I took the opposite of what was on the right-hand side. All right, that's going to work on this too. I can solve 2 equations. The one on the left, I'm going to keep the same. The one on the right, I'm going to go through and I'm going to change all those signs, okay? So let's show our 2 equations. All All right, so 4x plus 6 equals a 2x minus a 7. All right, again, or 4x plus 6 equals, now go through and change all the signs, negative 2x plus 7. All right, now those are simple equations. All right, we don't necessarily, and then here, like on something like this, I'm not going to take necessarily class time to solve that equation. You can solve that equation, right? We've got x on both sides. We're good at this point. All right, on this one, we should have gotten x equals negative 13 halves. And we're assuming I didn't make a mistake at that point. All right, x equals 1/6. Okay, so again, I'd probably write your answer in set notation. So negative 13 halves 1/6. Okay, and we ought to be pretty good there. The algebra steps there, I'm assuming, like I said, that we don't need to keep going over that because you're probably going to be pretty good at that at this point. All right, everybody good? Okay, guess what? Trajan, I'm going to call you out on this. You've been on your phone more than you have been paying attention to me. Is that your phone? Yeah, get rid of it. Thank you very much, sir. Okay. All right. Now these are just kind of nice little polynomial thing, you know, a little two-step equation, x on both sides. Okay. We're not going to do just simple equations like that anymore. How about if we throw a rational function in? And the only reason that I want to do this is because if that first algebra step is not done right, then it's going to create some problems for you. So let's do x plus 2 over a 2x minus 6. And then let's just put a nice little 4 on the right-hand side. All right, so basic setup on this is not too bad, right? We break it into two equations just like we have. That's the part, you're not going to have problems with that. Okay, so you're going to go x plus 2 over 2x minus 6 equals 4. Okay, you're going to do it again. You're going to go x plus 2 over 2x minus 6, and then it equals negative 4. Okay, so we're so far so good, right? Now, how am I going to solve that? Josiah?
If I'm correct, if you multiply both sides by 2x over 6.
Yeah, that'd be the easiest thing. This has got a fraction, right? I want to get rid of that fraction. I don't want fractions in here. If I take whatever's in the denominator and multiply both sides of the equation by that, 2x minus 6, all right? And then multiply it over here, 2x minus 6. All right, the 2x minus 6s are going to cross out on this left-hand side, which is what we want. All right, that eliminates that fraction. You got an x plus 2. Over here, you probably could go ahead and distribute that in that next line. So 8x minus 24. Now you're down to a nice little equation that you can solve. We can do that the rest of the way down. I think we're going to get x over 26 over 7. All right, now notice what I've done so far. On the last example, I had negative 13 halves. Okay, you're in calc now. You don't need to necessarily turn that into a mixed number. Don't turn it into a decimal. I'm not going to do anything with that. I'm just going to leave it 26 over 7. All right, we're going to see some ugly numbers like that. Nothing says that you have to completely, simplify and go all the way down like you have in earlier math classes. Okay, so here again, I'm going to multiply by that 2x minus 6 so that the fraction goes away. I'm going to do it on this side as well, 2x minus 6, and I'm going to do some distributing there. I'm going to go ahead and put that or back in here because I'm running out of room here. X plus 2, and then on the right-hand side, if you can go ahead and distribute that all in the same step, negative 8x plus 24. Again, don't let me screw this up. All right, pretty sure this is going to be like 22 over 9. But again, those improper fractions, perfectly okay. All right, perfectly okay. Use that set notation. All right, 26 over 7, 22 over 9. And honestly, a lot of people want these numbers placed in order from smallest to largest because it's a set. I don't get overly obsessed with that. Get both numbers in there, I'm going to be pretty pleased. Okay. All right, so there's our absolute value equations. All right, is that enough for review on that? Because we did that quite a bit last year. Okay. All right, now we're going to take the inequalities. Okay, we solved inequalities last year, and we did it a lot of different ways. I introduced the number line to you, I think. and we kind of plugged in some numbers into the original equation and got a feel for whether it was positive or negative, and we kind of can look at end behavior. Okay, so hopefully I did enough with you last year that this is going to be a smooth transition. Okay, so we're doing inequalities now. Okay, so let's say you've got 2x minus 4 times x squared minus 9, and then that's less than or equal to 0. Okay, so we've got an inequality here, and we need to solve it. Okay, answer is going to be in interval notation. All right, and if you remember how we talked about this, how we approached this last year. All right, this over here, if I multiply it out, I'm going to have some type of polynomial curve, right? It's going to be an x to the third with a positive leading coefficient. All right, actually, so let's go ahead and write that down. So my leading coefficient there is going to be, well, leading term even. Leading term is going to be a what? A 2x to the third, okay? I don't need to know what the rest of that is, because that leading coefficient, that leading term is going to tell me my end behavior, right? It's an x to the third, and it's a positive leading coefficient. We should have that memorized, so it's down, up, right? So our end behavior is going to be down, up on that, okay? Now, just in general, since I wasn't really necessarily ready to go that direction yet, this right here is going to multiply out to be some polynomial curve. I'm wanting to know, for me to solve this, I'm wanting to know, okay, where is this polynomial curve below the x-axis? Where is it below 0? Okay, so where is it negative at? Okay, that was our thinking. So what did we do? Well, we first found the roots. All right, this is in factored form, right? When it's in factored form, what? I can take each term and set them equal to 0. Okay, so if I set this one equal to 0, all right, 2x minus 4 equals 0, 2x equals 4, so x equals 2, I get a root right there of 2. All right, so these are my roots. All right, if I set this equal to 0, x squared minus 9 equals 0, x squared equals 9, so x equals plus or minus 3. All right, and then what do? We put them on a number line. Remember us doing the number line? Okay, so let's put them on the number line, preferably in numerical order. So I got -3 here, a 2, and a 3. All right, and then I should be able to plug numbers into my original function. All right, I'm going to assume this is called f of x. We're going to assume this function is f of x. Okay. All right, so I don't know, let's plug in a really big negative number. So a really big negative number here is going to make this whole thing negative, right? Don't let me make a mistake here. A really big negative number here, a really big negative number, positive minus 9, this is going to be positive. So negative times positive, the overall thing is negative. Okay. On this one, I'd probably plug in 0, right? So if I plug in 0, this term is negative. If I plug in 0, this term's negative. Negative times negative, it's going to be positive. All right. Okay, so not so fun here. 2.5. 2.5. All right, so if I plug 2.5 in here, and then minus 4, 2.5, let's do this over here. 2.5 squared plus 4, I'm going to have negative, right? One's positive, one's negative, so it's going to be negative. We don't always like to do the math in our head, but we can. And then again, oh, now if this is a really big number, though, a really big number is going to make that, it's going to make it positive, because a really big number here, positive times positive, so it'll be positive there. Okay, so you just want to, now again, a lot of the problems we do are going to alternate. Will every problem alternate? No. Okay, every problem will not alternate, so just don't get caught up into that. All right, so I want, this whole thing is saying, where is this polynomial curve below the x-axis? Where is it negative? So negative infinity to -3. All right, now, do you remember how to choose whether I have square brackets or curvy brackets on that -3? Yeah, the equal to part up here. All right. Less than or equal to, it's going to give me a square bracket right there. Okay, square bracket there. Skip over. All right, square bracket on the 2 to 3. Okay, and it's all based on that. These square brackets, I guess I should have put these in pink. These square brackets are all based on the part that I'm including those values in there. Closed dots. Wait a minute. Say that again. When they're included, it's going to be closed dots. When it's included, they're going to be closed dots. All right, so we good there? Okay, now, this original polynomial curve was in factored form, which makes it the easiest kind. All right, they are not all going to be in factored form. All right, so let's suppose we had one that looked like x to the third minus 6 is less than 3x minus 2x squared. Yeah, there we go. That works. Okay, not in factored form. I've got x's on both sides of the equation. Okay, so we don't want that. If I'm going to try to solve it, first step's going to be what? Move everything to the left. Okay, I go left. Wouldn't necessarily have to go up. Now, when I move these two terms to the left, might as well go ahead and put them in the order that we would like them in, so standard form. So I'm going to go x to the third. I'm going to add 2x squared. I'm going to subtract 3x. Then I'll have the minus 6 already over there, less than 0. Okay, so again, on this one, I'm looking for, to solve this, I want to know where is this polynomial curve less than 0 or below the x-axis. Okay, now it's got 4 terms in it. We got to solve it. What's the first thing you're going to try to do to solve it? Noah, say that really loud. Factor by grouping. You're going to try factor by grouping. Cross your fingers and hope it works. If factor by grouping does not work, yeah, there you go. Pick a God and pray. That works too. Okay. How about, do we remember the rational root theorem? Okay, rational root theorem. So factor by grouping is your first choice. Okay, and then rational root theorem is the second one. That's no. The rational root theorem is going to be that P over Q. You take all the factors of 6, and then you do synthetic division, and you try to get them to work. Synthetic division. All right, it's the P over Q's. So in other words, all the factors, and then you are then doing the synthetic division. Right. Yeah. Like, so your factors, you'd try things like -1, +1, -6, 6. You'd try 2 and 3 with one of them being negative, and then -3 and 2. I don't need a fraction bar in there, but you try all those factors, -1, 1, -6, 6, -2, 3, -3, 2, because this is always going to, in calc, when we encounter this and you've got to do rational root theorem, most of the time that leading coefficient is 1, so it's always going to be P over Q, and it's always going to be 1. So factors of this number right here, try them in synthetic division till you find one that works as a root. Okay, but this one, we don't have to do rational root theorem because this one does factor. Okay, so we don't have to do rational root theorem. So that's good on that. Let's go. I'm going to go ahead and get rid of this since we don't have to do rational root theorem on this one. All right, and with factor by grouping, I would group them together as they sit initially. All right, the only thing you might want to definitely make sure that you do is when you group them together right there, make sure that negative is in there. Okay, let's see what, we can factor out an x squared here. That'll leave me with an x plus a 2. What do I got to factor out of this one? Yeah, -3. That's going to leave me then with an x plus a 2. All right, and then keep factoring. What do? Technically, at this point, you're factoring out a binomial, right? Because this is your first term. This is your second term. You're factoring out that common binomial of x plus 2. And then that leaves you in this first term, when I take out an x plus 2, it leaves me with the x squared. And then out of this term, I take out that x plus 2. It leaves me with the minus 3. Okay, so clearly this one took a little bit more work because it was not in factored form. All right, again, set these things equal to 0 because this is the zero product principle. So I'm going to have a root here of x equals negative 2. Let's see, add 3 to both sides, take square root, plus or minus square root of 3. And I'm hoping that you can set something like that equal to 0 and do that in your head. All right, now again, you find those zeros, put them on your number line. Okay, so negative 2 is going to be the smallest, right? Because square root of 3. Negative square root of 3 is going to be a little bit bigger. So negative 2, negative square root of 3, and then square root of 3. All right, I'm kind of hoping like square root of like 3, square root of 2, you know, anything less than 10, you ought to be able to estimate really quickly in your head without a calculator. All right, I am going to label my number line f of x. I am assuming that this function is called f of x, okay? All right, now can you, where's going to be the easiest place to put it back into? Yeah, the factored form. When I'm trying these numbers, I'd plug them into that factored form. I'm going to give you just a few minutes, try to put in your pluses and minuses across here and see if you can do it right. Because that's the thing. If you can't fill in this number line, you're kind of in trouble at this point. Do a little bit of stuff in your head. I'm hoping it's a rough estimate. You don't need exact answers in there. You just need to know, is it going to be positive or negative? Okay, people do work at different speeds. I got some people I think are done. I'll talk while some of you are still working. All right, anytime you've got that interval where one's negative and one's positive, you always want to plug 0 in on that one, okay? Make life easy. And then when you've got something over here on the end, make it a really big positive number, okay? Then it makes the estimation in your head go a little bit faster. All right, so if we all did this right, let's see. I think this one was negative. I think this one was positive. This one's negative, and this one's positive. Did everybody, do we agree with me on that one? Okay. All right. And then there again, I know, I just said they don't always alternate. Okay. But this one does. All right. But now stop and think about this. Okay. Kind of stop and think about this. I mean, they wouldn't necessarily, it depends on whether they cross or they bounce. Okay. But I've got a cubic equation going on here, right? So we know like this, except what's going to happen is it's going to cross on every one of these. So it would become positive, it would become negative, it would become positive. I mean, we can kind of visualize what this graph looks like. Now, the reason why I say it doesn't always have to alternate is because technically, all right, let's see if I can pull out another color here. All right, couldn't I come up here and then possibly bounce? And then maybe bounce again, and then it still be a cubic, except this would be negative, negative, negative. Okay, so it will not always alternate. Right, yeah. Okay, so let's go ahead and write the actual answer to this one. Ignore that little green line on there now. All right, I want the part that's below the x-axis. All right, and again, we're looking at the sign. So it's a less than sign, so that means I'm going to be using curvy brackets. All right, so negative infinity to negative 2. Curvy, because that part's negative, and then curvy, negative square root of 3 to square root of 3 curvy. Okay. All right, so that's just kind of throwing back in some of the stuff that we did last year, and kind of hopefully it's like ringing a bell and kind of really sinking in a little bit easier this time. Okay, so I think for the next two examples, and then maybe we'll be done here. I might talk about, yeah, we'll be done after that. I'm going to do two very specific examples for very specific questions that are in tonight's homework. Okay, I won't always do that, but we're here still at the beginning of the school year. All right, so I'm going to baby you a little bit more. Okay, try to show you everything that you're going to encounter here. All right, let's do the directions. All right, you're going to see some things that are going to say find all values of the variables for which the radical represents a real number. Okay, so a very specific type question here. It's a thinking thing, so I kind of want to think this through. All right. Now, if they give you something that you can algebraically work out, well, okay, go ahead and algebraically work it out. All right, so let's say we got square root of x squared minus 3x minus 10. Okay, so it is a square root, but it's a square root of a polynomial curve that is a quadratic. All right, find all values of the variables for which the radical represents a real number. A real number. So this is a square root. If I take the square root of a positive number, do I get a real number? Right. If I take the square root of a negative number, I get imaginary, right? So that means that whatever's underneath this radical cannot be negative because I want to know what values represent a real number. Okay, that all makes sense? You got to read the directions and then actually think about what that's telling you to do. So in other words, this right here has to be greater than or equal to 0.
Okay, I was going to ask if we consider 0 real number.
Yeah, we are going to, yeah, yep. So greater than or equal to 0. Okay, so I'm going to take x squared minus 3x minus 10 greater than or equal to 0. All right, and then we just got done solving this, right? Because this is an inequality. Can we factor this one?
Yes.
Yeah, so let's factor because that's going to make life easier. X and x. And then what we got? 5 and a 2. 5 times 2 is 10. I need that 3 to be negative, so negative on the 5. Okay, so my roots are x equals 5, x equals negative 2. So there's my roots. Okay, so number line. I'm going to put that negative 2 on. I'm going to put that 5 on. All right, and again, I'm going to just assume that the function is called f of x. Later, that's going to get us in trouble because, yeah, but right now, we'll just assume. All right, and then we're going to plug some numbers in here. Let's see, really big negative number makes this negative, so negative times negative is going to be a positive. Okay, plugging in a 0, that'll be a negative times a positive, which will make that negative. Plugging in a positive, really big positive makes this positive, positive times positive is positive. Okay, so where is it? Where is the parabola greater than or equal to 0? Well, it would be here and here. Okay, so find all values of the variables for which the radical represents a real number. That would be all the values from negative infinity to negative 2. All right, square bracket or curvy bracket? Square bracket. Skip over, square bracket, 5 to infinity. All right, so this had lots of values, which makes the variables represent a real number. Okay, and then again, we know this is an x squared positive leading coefficient of 1, right? So we know what the graph's going to look like this. Remember when we drew those graphs on there, just kind of as a rough little sketch there, okay? All right, now, so some of the questions in this particular section, you're going to actually just be able to algebraically work out, okay? But then sometimes, before we even started though, we did a little bit of thinking. I am going to ask you to think. quite a bit here. Okay, so let's say we take the cube root of 8 minus 2x. Okay, cube root of 8 minus 2x. All right, now again, I want to know values of the variable for which this radical is going to represent a real number. Okay, so this one overall is a cube root. If I take the cube root of a positive number, I get a positive number. If I take the cube root of a negative number, you get a, what you did?
No, you get a negative number.
Oh, you guys are arguing. What's the cube root of negative 8? So what times what times what? Negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. Times negative 2 is a negative 8. Okay, so if I take the cube root of a negative number, I get a negative number. But is it real? Yes. All right, when I take the cube root of a positive number, well, we've already done it here, 2 times 2 times 2, I get a positive number. Is a positive number a real number?
Yes.
Yes. There's nothing else I could plug in, right? So it's a cube root. So what values of the variables will make this expression a real number? All real numbers. Because it doesn't matter what I plug in, all real numbers are going to do it. Okay? All real numbers I can plug in. But see, you got to think about it. And you might have to write some stuff down. You might have to plug it in. You might have to play it. Do some trial and error if you need to. Like plug it in and see what happens. Plug it in and see what happens. Okay? So all real numbers. Did I show you guys this last year? Double bar R for all real numbers. Okay? All right, you can write it out. You can, that notation you kind of ought to get kind of used to regardless.
So we write it like that instead of an interval?
Yeah, that was the other way. If it says interval notation, negative infinity to positive infinity. Yeah, that's interval notation, but I'll take the other way too. All right, now the only other thing that I might point out, all right, there's a lot of stuff in the online notes. There's some extra handouts under online notes and stuff, but if you don't have memorized, all right, we didn't run into anything today that was a perfect cube, all right, but this is what was our SOAP formula from last year. Same, opposite, always positive. All right, if you don't have your factoring memorized, I would probably, brush up on that. Solving any type of equation and factoring any type of factoring that we did last year, those are the two crucial things for this year, okay? You're not going to make mistakes in calculus. The mistakes you make in calculus will not be calculus related. The mistakes you make are going to be algebra. You're not going to be able to factor something. You're not going to be able to solve something, okay? So in all honesty, the calculus itself is not hard. You're gonna learn how to take the derivative. Like nobody in the room is going to screw that step up. But after you take that derivative, you're going to have to set it equal to 0 and solve. All right, and all that algebra, like we're going to do 1 or 2 steps of calculus and then like 2 pages of just good old-fashioned cranking out algebra stuff. That's where the mistakes are going to come. Okay. All right. So I think we're good. Anybody in the room got questions? Well, good. Anybody at home got questions? If you do, you just got to unmute your mic and go, hey, I got a question. All right. So I think if we're good, all right. You know where to find everything on the website. You're checking your Gmail every day. You're checking Google Classroom every day. All right. Check that calendar just constantly since we're doing this whole half of you at home, half of you at school type thing. So, all right. I'm going to shut up. I'm going to let you talk, or I'm going to let you work, not talk, work the rest of the period preferably. All right. We're in here till about 10:35. So nice amount of time to work. All right. So if you're at home, definitely thanks for joining me. And I think I'm going to, oops, there's a chat before I